I welcome you to today's class, our maths class. And our topic of discussion today is decimal places. This topic is not very difficult, but if you don't understand it, it can turn to a difficult question for you. And one basic thing about this particular topic is that it's all about where to start counting. This is dot. If you have numbers this side like 1, 2, 3, and you have numbers this other side 4, 6, 7, and you have to convert this number to maybe 1 decimal place or 2 decimal places, where will your counting start from? That is the main thing. Will it start from here? Will it start from here? Or will it start from here? That is the basic question that we need to answer through this our subject today. Follow me and you will understand it very clearly. And to treat this question, I'll use some questions to treat the topic. Let us use the following questions. To explain decimal places. Number 1. Look at this question. Approximate this number 253.06 to, let us start with 1 decimal place, to 1 dp. This is decimal place in short form, dp. This is the question now. How do you answer this question? Solution. To answer this question, you write out the numbers again, as in write 253. Put the point 06. To answer questions in decimal place, the counting of the decimal place starts after the decimal point. These numbers before decimal point, they are part of the question, but our count will not start here. Neither will it start here or here, but it has to start from here. So in that case, this is our first decimal place. First. This is the first decimal place. This is second decimal place. But since the question say convert approximate to 1 decimal place, so we'll stop here. So in lifting the answer now, you bring this 2 here, bring this 5, bring this 3, put the point. This is the 1 decimal place, 0. But this number after the 1 decimal place that we are required to place it is above 5. And as far as the number here is like 5 and above, we have to round up by converting this number here to 1, and they add to this one. This one will become 1. 0 plus 1 is 1. So what we have here now becomes 253.1 answer. So this is how to solve questions in decimal place. Let me give us another question that will explain further. Number 2 question. Approximate these numbers 74.543 to 2 dp, 2 decimal place. So this one here, the question wants us to convert this one to 2 decimal place. Let me start this side. Solution. Write out the numbers first. 74.543. Our count will not start here and it will not start from here because the counting of the decimal place in decimal place fractions starts after the decimal point. So you just write this 7, write this 4. They are part of the answer, but the count will not affect them. This is where our counting starts. So this one here, this is the first decimal place, and this is the second decimal place. So since we are required to convert it to 2 decimal place, don't bother about the 3rd decimal place. So we are stopping here. So as you have written this 774, put points, you leave this 5, write the 5 here. The next is supposed to write is 4. First of all, you look at this number after the 4 to know if it is up to 5 and above, so that you can round up. But since it is below 5, you round down by calling it 0. And when you add 0 to 5, it is still 5. When you add 0 to 4, it is still 4. So what you have here is 74.54 answer. As simple as it is, any student that does not understand it very well, it can confuse and continue to confuse such students. Watch another one, number 3 question. I put it in different forms so that to see if it is now very clear to us. Approximate this one. Approximate. Watch this one now. 0.001658 to 3 decimal place. The first one is to 1 decimal place. The second one is to 2 decimal place. This third one now is to 3 decimal place, and they have 0.00. Let us see how we can solve the solution. Lift the numbers. You have 0.001658. Where does our counting start? Immediately after the decimal point. Whether this number here is 0 number or non-zero number, it does not affect our counting. The counting starts after the point. So any number that is here, you start counting. So in that case, this is our first decimal place now. This is first, this is second, and this is third. And the question requires us to convert it to 3 decimal place. So we'll stop at this level. So now leave them down. You bring this 0 here, bring this 0, bring this 0. This is the 3rd decimal place where we're supposed to stop. 1. But you must surely look at the number after 1 to know if it is up to 5 and above or it is below 5, so that you know whether you round up or you round down. And in this case, as you can see, this is 6, is up to 5 and above. So you round up by converting it to 1 and add it to this 1 here. It becomes 2. So what you have here becomes 2. And that is your answer. This type of question used to come often in JAMB or even WAEC, OBJ. And any student that doesn't know it very well will continue to fail and fail. At the end of the day, they will say, I wrote very well. He wrote very well, but you failed. No admission. Does it make sense? Watch the next one that I want to talk about. Watch this one. Let me even clean this. See another angle that the question can also come. Approximation. Approximation in whole value system. Approximation in whole value system. So this one, I want to look at numbers that doesn't carry decimal points. Numbers without decimal points. How do we solve it? If they tell us to convert to 3 decimal place, or if they tell us to convert it to the nearest 10, nearest 100, nearest 1000 or 1 million, how can we get the answer? Watch now. One important thing, note. One important thing about this one is that ensure to know the number of zeros that are there in, first of all, 10. This is 10, as in 10. How many zeros are here? 1 0. This is 100. 100. How many zeros are here? 2. This is 1000. 1000. How many zeros are here? 3. This is million. These information are very important. How many zeros? Okay, this is 1 million. 0 0 0, 0 0 0. How many zeros are here? 6. 1 2 3, 0 0 0. Once you know this information at your fingertips, it will help you to answer questions on decimal places that involves whole numbers. Watch the next question I want to set now and see whether it will be easy to solve or difficult to solve based on how you understand what we are talking about. Watch. Look at these questions. Question number 1. Under whole number value system. Number 1. Approximate approximate 71, 089 to the nearest 1000, to the nearest 1000. So sometimes the question is not just to the 2 decimal place, 1 decimal place, but to the nearest 1000 or nearest 10. How do you solve this one? Watch. Solution. You write it out. 71, 089. Here we say that 1000 carries 3 0, 1 2 3. Come here. Convert this one first to 0. Convert this to 0. Convert this to 0. You have gotten 3 0, which is 1000. Then this 71, that is this side after the 3 0 that forms 1000, you bring it here. As you bring this 7, first of all, look at the number after this 71. The next number here, if it is up to 5 and above, you round up by calling it 1 to add here. But if it is below 5, you round down by leaving it as 0 as it is. Therefore, what shall be here should be 7 and 1. You put here comma. So instead of saying 7,189, they say convert to the nearest 1000. Don't mention 100 or tens and units, all that. Therefore, 71,000 becomes the answer. This is how to convert this question, this figure, to the nearest 1000. Watch another one. Number 2 question. Express. The question can say approximate or express. Express 14.4614 to the nearest whole number, to the nearest whole number. This is another way the examiner can test you in the exam. How do you solve this one? Solution. Write the number out first. 1,4.461,4. Convert it to the nearest whole number. As you can see, when you have this number like this and have points and have other numbers, the whole of this number is not a whole number. It's the decimal numbers. But you are required to convert it to whole numbers. Numbers that can appear without any point among them. So how do you do it? This is the whole number. As you write this one, you bring this one down. Before you write this 4, check the number after this 4, because these 2 are the whole numbers. These ones are not important. If you like, you can convert it to 0. This is 0. This is 0. This is 0. Before converting this one to 0, you have to observe well. If it's up to 5 and above, you call it 1 and add here. But since it's below 5, you also call it 0. Then you bring this 4 down here and put your point. This is our interest. So answer now is equals to 14. These ones are not part of what we are copying as our answer. Since they appear after the point, they are not important to us again. The question says convert to the nearest whole number. So how to convert this number to the nearest whole number is only this 14. Since this one is not up to 5, you throw all of them out and leave only 14. That is your answer. Let me still show us another one that will help us to understand it even more. Let me clear. Try to follow up, understand these questions, so that things, small things like this will not make you to fail your exam. Let me show us the last one, number 3 question. Express 50,769 to the nearest hundred. To the nearest 100. And before we say that 100, which is like this, has 2 zeros, which is 1, 2. In order to answer this question now, solution. See how to solve this question. Since we say that 100 involves 2 zeros, watch now. As I write the number, which is 50,769. 100 involves 2 zeros. So as you convert this one to 0, convert this one to 0 to form the 100. Then this number here, before you convert it, before you write it down, check the number before it. Already, here this one is 50,000. But this one I want to convert to the nearest 100. So after this very number, as in if you watch 100, you have 1, 0, 0. So you have 0, 0. The number that's supposed to be here is this 7. But before you leave the 7 down, watch the number before it. If it is up to 5 and above, you round up by calling it 1 to add here. And they now have 800. This is our answer. But the way they said this question in OBJ, they will give you options that are closer to this one. They will give you 50,700, 50,900, 50,400, different figures. If you don't know it very well, if you convert this one to 1 and add here, you have failed it. If you convert this one to 1 and add here, you have failed it. This very one, after this is 100, 0, 0. The next number here, just like this one is 1. It can be 1, it can be 2, depending on the number you have. You convert this one to the number that's supposed to be here to form the 100. So as you add 1 here, become 8. So you have 50,800 as the answer. Thank you very well. Thank you very much for joining us in today's class. And I welcome you next time. I want you to take your time when you go home, go through the teachings, check the solutions, how we solve it. Anyway, you have question, do well to type your question on the comments section subscribe, follow us.